Alright guys, let's try this out. This is where I should have started Thermochem, but it's alright we're starting it here, since we still need to learn about atomic trends and none of that has changed. So, first of all, Thermochemistry, this is what we're studying, and this is a great meme. Chemists are just many atoms that talk about atoms. This is one of the wonders of the universe. How can a bunch of atoms which are dead, or at least not living, come together to make a living thing that knows it's alive and knows it's made of atoms? I like to think about this as like if you had a giant Lego set. Imagine so in this analogy, each Lego piece is an atom. And you make this Lego set billions of Legos, made up billions of Legos, and then suddenly it turns to you and says, "Hi, I am made out of Legos." It makes absolutely no sense, and it's a fantastic mystery. Another meme here, we will not understand this one until we do um, aqueous solutions, but it's very funny, you can take my word on that. So, everything you know about electrons is wrong, and you probably have learned it like this. We've got 2 electrons in our inner shell, and then up to 8 in our second shell. This is a 2D representation, but you need to remember that atoms are 3D. So what does that mean? It doesn't look like this, and instead it's going to look like this. So hydrogen has got 1 proton and 1 electron. You might imagine it like this, except the electrons is 3D, and it's going at about 50% the speed of light. So instead of making our atom look like this, it kind of looks like this. This is a snapshot of where the electron is. It's modeled, and so each dot is where it is at a moment in time, and 95% of the time it is within this red circle. Okay? So we actually call this our atomic radius. This is our atomic radius because most of the time the electron's within here. 95% of the time the electron's within the green sphere, which is this one, and we call this an orbital. So this is our 1s orbital, and it's just saying the electron's likely to be in here. Okay? That's all that's saying. So this is pretty cool, and it doesn't matter if you don't fully understand this, but just something that I think is pretty cool. So this is electron density in terms of our hydrogen atom. And this is our nucleus here, and this is the probability of finding an electron around the point. So as we get closer to the nucleus, the probability of finding the electron there is higher, and it falls off over time. So as we get very far away from the nucleus, it is very unlikely for us to find an electron there. Okay? It's just electron density, represented by this plot. Okay? Lots of points close to the nucleus, few points further away. Now this represents the same piece of data, but it's slightly different. So probability curve of finding an electron r distance away from the nucleus. And what this means is it actually peaks here, and then it goes down. Why it's 0 at the nucleus is because at the nucleus it's so tiny that the probability of finding an electron there is very small. But as we go out, the area of the circle starts to get bigger, or the area of the sphere starts to get bigger, and you're hitting more of these dots. So you're hitting the most dots this distance away from the nucleus. And in fact, it never goes to 0. You can find an electron across the other side of the solar system for your atom, in theory. So this is the most common distance, and we call this the orbital distance. Okay, so we looked at the 1s orbital, and I'm going to spend quite a bit of time explaining this. This is our periodic table chunked into orbitals. Here, in the first 2 columns, is our s orbitals. Okay? S, 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 S. S orbitals can only hold 2 electrons. Okay? So hydrogen is 1s, and it's actually 1s1, because it can hold 1 electron. Helium has got 2 electrons, so we call this 1s2. It's in the 1 means row on the periodic table. Okay? As you see, this is 2, this is 3, this is shifted down 1, we'll get to that in a bit, but let's look at the first 3 columns. 1, 2 here, 3, 3 there. This means the first 2 ones here is S, these ones are P, these ones in the middle are D, and we won't have to worry about these ones at all. Okay? Don't panic if this doesn't make sense just yet. So, this is what you have to take down in your books as notes. S orbitals. They can hold 2 electrons each, e.g. 1s, which is here, can hold 2 electrons, while 2s also holds 2. We write this as 1s2. What this tells me is we've got energy level 1 in our s orbital holding 2 electrons. Okay? And this is our 1s orbital over here. So in this little sphere, we can have 2 electrons. Write it down in your book. You don't have to draw this. Just write this part down. And this is also a very important thing to write down in your books. So 1 means the electron energy level, determined by rho on the periodic table. The S means type of electron orbital, determined by the column on the periodic table. And 2 is the number of electrons being held. So hydrogen is 1s1, as hydrogen only has 1 electron. This is 1s2, so this will be helium, because helium's got 2 electrons. Write this down in your books. Fantastic. Yep. As we call these blocks, we've got the S block here, and we've got the P block here. And D block is in the middle. And as we can see, the energy levels increase downwards. As you may think of like electron shells, we call these energy levels. Okay. This is the almighty order. And what does this mean? 1s, 2s, 2p, 3p, 3p, 3d, 4s, 4p. So this is the order of how we fill up our electrons. Okay? So we can just read this by going across the table. So let's go across the table. We start at 1s, 1s, 2s, 2p, 3s, 3p. I'm going to change this actually. I taught this last year and I think it's easier to do this. 4s, 3d. I'm going to change that around. And so you can remember this as sea snake, poisonous snake, painful death, so it's meant to be PD, and then stupid person. But we actually fill up the 4s before the 3d. So this is the order, and let's just do an example really quick. Okay? So let's take an element like carbon. Okay? Carbon is right here on the periodic table, being element number 6. So it's in the 2p block. But it's also got everything before the 2p block as well. So for example, carbon with 6 electrons, we need to start at the 1s. So it's going to be 1s2. And so that's 2 electrons accounted for. Then we're going to get 2s2. Need to make these 2's small somehow. And then we're going to have 2p2. Let me just fix all these 2's. Awesome. So this is our carbon, and this is what it looks like for carbon. And if we count up all the electrons, we've got 6 electrons here. So 2, 2, 2. Add that all up, we get to 6, which is carbon's got 6 electrons. Fantastic. And it's got 2 electrons in the 1s orbital, 2 electrons in the 2s orbital, and 2 electrons in the 2p orbital. So that's what I mean by this order. Okay? So Last notes for today, p orbitals. P orbitals are split into 3 suborbitals. Each suborbital can hold 2 electrons. Each one is spin up, 1 spin up and 1 spin down. P orbitals can hold 6 electrons total. 2p6 represents the 2p orbitals holding 6 electrons total. If you can take down those notes, that is all we're going to do today, and then this task is going to be in the Google Classroom for you to have a go at. Okay, thanks guys for watching.